Alright, so this is the 2012 paper, okay? So Newton's law of cooling says that the rate of cooling body is proportional, once again a proportional question, to the difference between the temperature of a body and the temperature of the surroundings. If theta is the difference between the temperature of a body and temperature of surroundings, then the theta dt, so the change in temperature with respect to time, equals minus k times the difference of the surroundings. Body cools from 80 to 60 in 10 minutes. The temperature of surrounding is maintained at 20 degrees. Find the value of K. Alright guys, so we start off with the theta dt equals minus K theta. We then bring the variables to the same sides. So 1 over theta d theta equals minus K dt. We now got to put in some limits. So what happens is, okay, in 10 minutes, body cools from 80 to 60 in 10 minutes, and the temperature of the surroundings is maintained at 20. Okay.
Is theta the change, or?
Theta is the difference between the temperature of the body and the temperature of its surroundings. So, yeah, so for instance, it'll be 80 minus 20 to give you 60. And then it will be 60 minus 20 to give you 40. That's what's defined as. So that's why the limits are funny here, okay? So for instance, 10 and 0, okay? After 10 minutes, its temperature is 60, okay? But we don't use 60 as the upper limit because it's defined as the difference. So technically the top limit is 40. And to begin with, you're at 80 degrees, but 80 degrees is 60 above the surroundings. So that's why we have our 40 and 60. That's your first 10 marks, right there, once you successfully integrate. So we're going to get ln theta from 40 to 60. Okay, from 40 to 60. And then we're going to get minus kt, which is 10 to 0. And minus kt. Integrate both sides, we get ln 40 minus ln 60, that equals minus 10t. Multiply both sides by negative 1, so we get ln 60 minus ln 40, 10k, sorry, yeah, equals 10k, and then ln 60 divided by ln 40 is going to be ln 60 over 40, which is ln 3 over 2. ln 3 over 2 equals 10k. K therefore is 1 over 10 ln 3 over 2. Okay. So in this question here, right, the temperature of a body after a further 15 minutes. A further 15 minutes could be in the context of 10 minutes, giving it up to 25 minutes total. That's one way of interpreting it. According to the marking scheme, what they want you to do is just 15 minutes in total. Okay, so look, we'll do 15 minutes in total, and then we might see about doing the 25 minutes after that. Now, your integration, like last time, is it's basically the same thing, okay? But there's some differences in this part here. Now, the differences is as follows, okay? First of all, whatever your end temperature is, it says you have to take away 20 because it's defined as the difference between your temperature and the outside temperature. So that your end is going to be theta minus 20. Your start is going to be So guys, look, it is actually an additional 40. So look, what we can do is we can go from 0 to 25 if we want. There's two different ways of doing this. So I'm going to try to go from 0 to 25. Okay? And then just take away, just find what the temperature is, okay? So it's going to be theta minus 20 on top. On the bottom it's going to be 60 because at time 0 there's a 60 Celsius change between the outside temperature and the 80 degree temperature. So, and then I'm going to integrate, okay? So I'm going to integrate like last time, except with one or two little changes. So what we're going to do is we're going to leave the k value here because we're going to need it soon, and this here changes to theta minus 20. And this here is 25 and 0. So we're going to get minus 25k, and that's going to be equal to ln theta minus 20 minus ln 60. Okay, and then upon doing that, we're then going to multiply both sides by minus. So we have minus that plus that plus that. Then I'm going to use the log rule, so I'm going to have ln 60 over theta minus 20, all in brackets. Then we're going to take equals 25, and I'm going to put in what k is. 25 times 1 over 10, ln 3 over 2. Now that this is done, what we can next do is what we can do here is we can say that that's 2.5 ln 3 over 2, and we can say that that's ln 60 divided by 60 ln 60 divided by theta over minus 20. Now I can't strike off the ln's at this point in time because of the presence of the 2.5, but I can use the power rules of logs and bring it in here. So I'm going to get 3 over 2 to the power of 2.5, and then I'm going to get ln 60 theta minus 20. Okay, strike off ln off both sides, and I'm going to get is, and then what I'm going to do is bring up going to find out what 3.2 to the power of 1.5 to the power of 2.5 is, and that will be 2.7756. So 2.756 is what all this is here, and that is going to be multiplied by theta minus 20. Okay, so it's going to be theta minus 20 up here, and all of that equals 60. Then we're going to multiply it out, so it's going to be 60 minus, that's going to be 2.756 theta. So we're going to multiply 20 by 2.756. Oh, sorry, 2.756 multiplied by 20, and what we get there is 55.12. So we're going to take away 55.12 away from 60. And what do we get there? Sorry?
4.88.
Oh, we're adding. Sorry, excuse me, we're adding because it's negative on that side, so it's going to be 105.12 equals 2.756 theta. Sorry? Oh, 115. Now divide 115 by 2.756. Was it?
41.77.
41.77. Okay, is that the correct answer? 41.77. A particle of mass m is fired horizontally through a block of resistive gel. So look, we have a sort of block of resistive gel here. Then the particle comes in, gets fired, and then subsequently gets slowed down within the gel. Okay? The resistance to the motion, now keyword being resistance. Resistance means negative, losing acceleration, losing speed, and it's proportional to its velocity. Okay, the particle enters the gel at a speed of 1,000 meters per second, and 100 of a second later exits the gel at a speed of 10 meters per second. Show that k equals 99 over 10. So acceleration is change in velocity over change in time. Change in velocity over change in time is minus kv v squared. Why did we drop the m? Because force is ma equals minus mkv squared. The m's can cancel, and that leaves you your minus kv squared. Okay, next thing after that is to isolate the variables. So we're going to have minus k dt on one side, and we're going to have 1 over v squared dv on the other side. Okay, and we're going to integrate them. Okay, upon completion of that, okay, what we got to do is we got to pair up our numbers. So, if this is 0, it enters in at 1000 at 0. It exits 0.01 later. Okay, because it's 100 of a second later it exits, and we want to find out what's the exit speed? 10. So there we go. We have our limits linked up now. Sorry? The limits the other way around. It doesn't actually make a difference. Once they're paired off, is like I can't flip one of them upside down without flipping the other one upside down. So once they're at the same level, the information at the same level, then you're safe. Okay. So next we're going to integrate, and we'll get what are we going to get here? That's phi to the minus 2. So it's going to be phi to the minus 2 is going to be minus 1 phi to the minus 1. Okay, so it's going to be minus 1 over v when we integrate from 10 to 1000, and then it's going to be minus kt 0.01 and 0. Okay, so we get is minus 1 over 10 minus 1 over 1000 equals minus 0.01 k. Oh, it's double negative as well. So I forgot the double negative there. So it's technically minus a tenth plus a thousandth. So minus a tenth minus a thousandth. Oh, sorry, plus a thousandth. It's going to be minus 99 over 1000. Minus 99 over 1000 equals minus 0.01 k. Divide by minus 0.01. (99 over 10). Is that where we're at? K equals 99 over 10. Perfect. Okay, again, k equals 99 over 10 was worth 20 out of 25. So you can see the next 5 marks are actually a lot of work for 5 marks. Okay, next part. Use the fact that 1 over 9900t plus 1 equals 1 over 9900 ln 9900t plus 1 plus c, or otherwise to show that the length of the block of gel is 10 over 99 ln 100. Okay, what we're doing is we're linking this into a distance question, the change in distance. Okay, we can call this distance 0 and the end s. Now the reason why we can call it 0 is because when you first enter in, you basically have your velocity is starting at 1000 and it hasn't travelled any distance through the block. So the way I would do this is I might do this a slightly different way. Okay, so I suppose 2 different ways of doing it. Okay, you could go back to the start, and what you could do is you could change the VDT into phi times the VDX. Okay, so we can change the v dt into v times the v dx. So using distance way, just minus kv squared. And then what we're going to do next is we're going to divide by v. So we're going to bring down the v squared, and we're going to get 1 over v dv minus k dx. Now, matching up the limits is going to be important. Okay, so it exits at 10, which means it's covered the distance s of the full block. It entered at 1000, which means its distance was 0. Integrate both sides, and what we should get is ln v from 10 to 1000, and that should equal minus k into s and 0. So it's going to be minus, now what did we say k was again? 99 over 10. So it's going to be 99 over 10s, or minus 99 over 10s. And what was ln 10 minus 1000 last time? We did it before, didn't we?
No.
Oh, sorry, we didn't, because yeah, you're right. So it's going to be ln 10 minus ln 1000. Multiply both sides by minus 1. And then we're going to get ln 1000 divided by 10, because that's the subtracting log drill. That equals 99 over 10s. Then divide by 99 over 10, and we'll get 10 over 99. And then ln 100, 1000 minus 10 is going to be ln 100 equals s. So that's our distance there. Okay, and it doesn't necessarily need it in decimals. Alright guys.